Okay, welcome back, students. We're going to go into section 4.3 here, tangents and cotangent functions. Let me share my screen. All right. Okay, graphs of tangent and cotangent functions. For the tangent function, we have these things called asymptotes, and they occur at negative pi over 2, and any subsequent odd number pi over 2, like 3 pi over 2, 5 pi over 2. So this one over here is at 3 pi over 2, 5 pi over 2, and so on. Okay, and it just repeats. The period is pi, because we can see that it goes from negative pi over 2. Let me zoom in on this one. Negative pi over 2 to positive pi over 2 is one cycle, but that spans pi units. Okay, that's a period of pi. Okay, it spans pi units there. Now, the nice thing about tangent is that we know what happens at pi over 4. At pi over 4, this thing is at 1. Okay, because the tangent of pi over 4 is 1. And if we did negative pi over 4, then this thing is at negative 1. And the tangent of 0 is 0. So we really have basically five values here that we're working with. Okay, we're working with the, let me go, this is negative pi over 4. Okay, the asymptote is at negative pi over 2 and pi over 2. So those are two values that we're working with. And then at the pi over 4s, we're at negative 1 and 1. And at the 0, we're at 0. So that's basically the parent function for that one. Okay, and we can write more intervals if we want, more periods, more cycles of this if we want to graph more of it. But it just it'll repeat over and over again every pi units. Okay. Okay, what about the cotangent function? The cotangent function is like the tangent function, except that it's kind of a mirror image of it, and it's shifted. Okay, so it's a mirror image, and it's shifted over pi over 2 units. So instead of being at negative pi over 2, okay, the whole thing gets shifted over pi over 2 units, and then it gets kind of flipped. If you were to look at this axis here, okay, it would be flipped, okay, across that mirror image there. It would be flipped. Okay, this line is not an asymptote. It's just a line of reflection to show you that you would get it to be reflected from the cotangent is a reflection of the tangent function, but it's just shifted up pi over 2 units. Okay, so instead of starting at negative pi over 2 as the asymptote, we start at pi over 2. I'm sorry, we start at 0. And then instead of the other asymptote being at pi over 2, it's at pi. So we actually end up going up every pi units. This one would be at 2 pi. Every pi units would be another period, another cycle. Okay, and again, at pi over 4, the cotangent is 1. At 3 pi over 4, the cotangent is at negative 1. And at pi over 2, the cotangent is 0. So we have these 5 values. Again, the 0, the pi over 4, okay, give me 1. The pi over 2 gives me a 0. The 3 pi over 4 gives me a negative 1, and the pi gives me an asymptote. Okay, so those are the reference values for the tangent and cotangent function. Okay, okay, let's look at how to graph this guy. It says graphing the tangent and cotangent functions. Step 1, for the tangent, find an interval from 1 period by setting the argument between negative pi over 2 and pi over 2. So that's going to be one period. Okay, for the cotangent, it's 0 to pi. Okay, sketch the vertical asymptotes and then divide the interval into 4 equal intervals or subintervals. Okay, evaluate the function of the 5 labeled x values. Okay, so where are those asymptotes going to be? Where are those 1 and -1 values going to be? Where's that 0? Okay, that's kind of acts like the midline. This 0 function, this 0 point kind of acts like the midline. Okay, it's not a midline, but sorry, it should be a horizontal. It's not a midline per se. It'd be a horizontal, a vertical midline instead of a horizontal one this time. Okay, but it kind of acts like a vertical midline. Okay, where that 0 value is located. Okay, sketch the vertical asymptotes and divide into 4 equal subintervals. Evaluate the function at the 5 labeled x values. Plot the points from step 3 and draw the curve approaching the asymptotes. And if needed, we may draw the graph over from more periods. Okay, so let's try this. Let's graph a couple of these. Okay, we're going to graph y equals -1/2 tangent x over 1 period. So this is very similar to the same structure as the sine function and cosine function. We have y equals c plus a tangent b times x minus d. Okay, and so this thing, we could put brackets there if we wanted to, but this is gonna it's going to stretch, a is going to stretch the function, b is going to create what I'll call it, is going to basically compress the function or expand it vertically. Oh, it's going to change the period. Okay, b changes the period because it's a horizontal compression or expansion. Okay. But in this case, the period is going to be pi. So the period is, if b is 1, the period is pi. And so instead of being 2 pi over b, we get pi over b. A is, we could think of it as the amplitude, but it really isn't. A is just going to be where my 1 and -1 values are. So maybe I should go back here and say A is where those -1 and 1 values occur. B is B tells me that if I have pi over b, that's the period. And then pi over 4b are the divisions. Okay, those are the divisions that we're going to get those 5 values for. C is just a vertical translation, up or down. C equals vertical translation. And D is just a phase shift. Okay, very similar to what we had before. Okay, so let's go ahead and graph this. So what would A be in this case? A would be -1/2. Okay, and we have B would be equal to 2. Okay, C is 0 and D is 0. So that's nice. Okay, so what would the period be? The period would be pi over 2. And what would the divisions be? The divisions would be pi over 8 divisions. Okay. Okay, so let's draw a graph here. Okay, and so the the period is pi over 2, which means that that the whole thing is going to be pi over 2. The divisions are pi over 8s. So I'm going to go like this. I'm going to go pi over 8. Okay, 2 pi over 8 is pi over 4. Okay, negative pi over 8 and negative pi over 4. And at negative pi over 4 and pi over 4, those are going to be my asymptotes. Okay, because this thing got compressed horizontally by a factor of 1/2. Okay, so the period is only pi over 2 units. From negative pi over 4 to pi over 4 is only pi over 2 units. Okay, and so now we have a negative 1/2 for A. A was negative 1/2. So what's that going to do? Well, that's going to tell me that, whereas before I would have this guy, this value here and this value here at 1 and negative 1, those values are going to be at 1/2 and negative 1/2. And the negative, what's that going to do to the tangent? Well, the original tangent function looks like this. Okay, but if I throw a negative in there, it's going to flip this guy upside down. And so now, instead of being like this, it's going to be flipped. Okay, so this is if it's a negative, and this is if it's a positive. Okay, so a negative is going to flip it upside down. Okay, a reflection with respect to the x-axis. Okay, so instead of being at negative pi over 8, 1, we're at negative pi over 8, 1/2. Instead of being at, instead of being negative pi over 8, negative 1, we're at negative pi over 8, positive 1/2. And instead of being at positive pi over 8, positive 1/2, we're actually at negative 1/2. We're still at 0, 0 because we didn't shift horizontally or vertically. And so we really are getting a graph that looks like so. Okay. And so this would be our tangent function. Okay, let's try the next one here. Okay, y equals 3 plus cotangent x plus pi over 2 over 1 period. So we have a equal 1. Okay, b is equal to 1, so nothing really changes there. C is equal to 3, and D is equal to negative pi over 2. Remember, it's always opposite sign. If that's a positive, then the phase shift is negative pi over 2. Okay, so what does the cotangent look like? Well, the original cotangent function starts at 0 and goes to pi, and it kind of looks like that reversed tangent function. Okay, the one that's reflected. And so this is the original cotangent function, okay, with these asymptotes at 0 and pi, okay, and it has a period of pi, okay, and then we have these values at 1 and negative 1. Okay, so that's the original one. So how does this thing compare? Well, this thing is just going to get translated. It's going to get translated up 3, and it's going to get translated to the left pi over 2. Okay, so we're going to move the whole graph over pi over 2 units, and then we're going to move the whole thing up 3 units. So where it was 0 here, that's going to end up at 3. So we're going to go like so. The asymptotes, they get moved over pi over 2. So what's 0 minus pi over 2? Well, it's just negative pi over 2. Okay. And once again, the period here, if b is 1, the period is just pi. And so what would the divisions be? The divisions would be pi over 4. So pi over 4 divisions. Okay, so this is negative pi over 2, and then I'm going to get a division here at pi over 4. And then I'm going to get 1 at 0. And then I'm going to get negative pi over 4. And then I'm going to get 1 at pi over 4. And then I'm going to get 1 at 1/2, or pi over 2, sorry. Okay, pi over 2. Okay, so now what else are we doing here? Well, we're, instead of being at 0, 0, again, the original cotangent function would have been at 1 and -1, right? So it's kind of look like this. I'll do a rough sketch here. Okay, it would kind of look like this. Okay, cotangent. However, we only took into account the fact that it had a phase shift. We didn't take into account that it was actually moved up 3 units, right? So I can do a little trick here, which is I can either move the entire graph up 3 units. Okay, but if I've already graphed it, I don't really want to move the whole thing up 3 units. Or I can move the axes, this x-axis, I can move that down 3 units. So I'm gonna do that. This is 1, 2, 3. And so now I'm gonna move the axes down. So how does that change things? Okay, that axis is gone. Okay, and so instead of it being at 0 here, this is 0, this is 1, this is 2. Now that 0 point is at 3, and this is 4. Oh, okay, so this point was at negative pi over 4, positive 4. Nice, nice, nice. This is at pi over 4, positive 2. Nice. I'm gonna get rid of these. Oops. This is still at pi over 2. Okay, this negative pi over 4 went down there, and this is negative pi over 2. And we're good. Okay, looks good. Okay. Yeah. Okay, determine the equation for the cotangent graph. Now this is a cotangent, right? Not a tangent. Okay, and so what would I have had to do? This looks like a tangent graph. So how could I change the tangent into cotangent, or change the cotangent, you know, to make it look like a tangent? Well, basically I could just negate it. This thing I would want to have flipped, right, upside down. Okay, so I would have, now what's going to flip that original cotangent function upside down is a negative. Okay, so that's a negative. So A is -1. Okay, because we're not stretching it any. Okay, because they're each still 1 unit. They're going up 1 unit. However, it's not centered at 0. So we would have had to have pushed this up. We would have had to have pushed that up 1 unit. Okay, well, that's interesting. So C would be 1 unit up. Okay, we didn't have to do a phase shift, because the original starts at 0. However, this goes to 2 pi instead of pi. So we did stretch this horizontally. The period changed from pi to 2 pi. So if the period is pi over b, and now that's 2 pi, how are we going to solve for b? Well, we could cross multiply, and we would get pi over b, or sorry, pi times 1, which is pi, is equal to 2 pi b, divide by 2 pi, and we get b is equal to 1/2. Oh, okay. So b was 1/2, and was there any d? No, d was 0 because there's no phase shift here. Okay, and so when we unpackage all of this, okay, we would say that we would have y equals 1 minus cotangent. Okay, yeah, negative 1 would be there would be a -1 there, but 1 times cotangent is cotangent. Okay, of 1/2 x. Okay, this is 1 minus cotangent of 1/2 x. Okay, there's no d value. D is 0, so we don't have to deal with that. Okay. Okay, I will see you guys in the next video. Okay.